Episode 153 of CppCast with guest Robert Schumacher, recorded June 6, 2018. This episode of CppCast is sponsored by Backtrace, the turnkey debugging platform that helps you spend less time debugging and more time building. Get to the root cause quickly with detailed information at your fingertips. Start your free trial at backtrace.io/CppCast. In this episode, we discuss resources for learning C++ and macro expansions in Visual Studio. Then we talk to Robert Schumacher from Microsoft. Robert talks to us about Vcpkg and the Rapperswil ISO C++ meeting. Welcome to episode 153 of CppCast, the only podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm all right, Rob. How are you doing?
I'm doing okay. Don't really have too much news on my end. How about you?
Well, I think, so I've got another round of traveling coming up, but this should not affect our podcast, right? As far as we know currently.
Yeah, we got a couple interviews planned over the next few weeks, so we should be good.
Okay.
Yeah.
So I guess that's not really any news for our listeners.
Okay. Well, at the top of every episode, I'd like to read a piece of feedback. This week I got a tweet from Tony Lewis, and he was actually writing to CPP Chat, but saying that he's really enjoying the addition of CPP Chat to his podcast feed, and it really does provide something quite different to the equally great CppCast. And yeah, I completely agree. It's great to have another podcast out there. I think it is, different and unique compared to what we do. So it's more the merrier. We're glad that John and Phil are doing that.
So are they managing to maintain a regular release schedule?
I think so. I think this was like episode 30 that he was replying to, and I think the two of us, was that like episode 24 or 26?
Oh, well, yeah, then that would pretty much imply they are, yeah.
Yeah, good stuff. Well, we'd love to hear your thoughts about the show as well. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com, and don't forget to leave us a review on iTunes. Joining us today is Robert Schumacher. Robert is a developer on the Microsoft Visual C++ Libraries team and the lead developer for Vcpkg. He has previously worked on the MSVC implementation of the modules TS and is the current maintainer of Cpprestsdk. Besides work, he occasionally indulges in functional programming and arguments about whether inheritance is fundamentally flawed. Robert, welcome to the show.
Hi guys, it's great to be here.
Which side of the argument on whether or not inheritance is fundamentally flawed do you come down on?
Generally, I'm arguing with my office mate who is from a Java background, so I tend to be on the side that inheritance is a blight upon the world, if you will, and wouldn't we all be better if we just composed our structs in the true C way?
Well, yeah, I guess we could make arguments about Java's version of inheritance being fundamentally flawed.
Yeah. But it's great fun. It's great fun. We do a back and forth, and it's pretty good.
Yeah, that sounds like good office banter, just to give each other a hard time.
Yeah, definitely. Well, Robert, we have a couple news articles to discuss. Feel free to comment on any of these, and then we'll start talking more about Vcpkg and some other work you do, okay?
Awesome. Let's go into it.
Okay. So this first one is a blog post on Medium, and this is actually titled Teach Yourself C++, Where to Start. And this is from a programmer who is kind of new to programming in itself, but just decided to teach himself C++, and he kind of gave an overview of why he decided he wanted to learn C++ and some of the resources he used, including YouTube talks of CS courses and recorded conference talks and some of the books he read. And I thought it was a pretty good overview and could be useful to someone who wants to learn C++.
Yeah. I agree. Although, thinking about this article, I honestly cannot remember how I learned C++ initially. Because I know I didn't own any books.
You didn't.
And
you learned it
I did
before
not.
college. Yeah.
Well, when I first started playing with it, I mean, it was very rudimentary, just object-oriented programming, basically. I mean, to set it apart from C. But I didn't have any books, and I don't remember there being online resources available. I have absolutely no idea how I was aware of what the syntax was supposed to be. No memory of that. It's kind of funny.
Yeah.
How
about you, Robert?
I've had a similar... Yeah, I can't remember how I learned C++ initially. It's been so long. But when I was looking through the article, I noticed that a book that I would recommend was left off, which is a tour of C++. And I understand that is often targeted at people coming from other languages or people who are looking to update on C++. But it's really comprehensive. It's really concise, I would say. I don't want to say dense, but it's concise. It tells you what you need to know without necessarily too much fluff around it.
Yeah, I also definitely agree. And I believe there's a new version of a tour of C++ that's supposed to be coming out soon.
Yeah, I was just going to mention he did recommend one of Bjarne's other books, the C++ programming language, but the tour of C++ is definitely a good one, especially for beginners. Yeah. Okay, next one. This one comes from the Visual C++ blog. Macro expansions and quick info tooltips. And I thought this looked pretty handy. Basically, if you hover over a macro being used in the code, it'll show you what the macro definition is, kind of in line, but also show you, based on, whatever variables you're putting into the macro, what the actual, calculation will be. Like in this case, it's area of a cylinder, and it actually shows you, the numbers you're inputting and what the area is calculating out to.
Yeah. One thing that's better than having macro expansion with your mouse over?
What would that be?
Not using macros.
Wow.
Well, there was the other feature, I think you're probably going to mention it, that we talked about a few weeks ago, which is the replace macro with const_expr, right?
Mm-hmm.
Yeah.
Mm-hmm.
Oh, yeah, that's right. That's supposed to be in the latest version of Visual Studio, right?
Mm-hmm. We've been working pretty hard on that. I believe Cody Miller is our developer who's been working on that. He's on the front-end team. And he's a smart guy, and he's been doing some really, really cool stuff with that. And there's a lot of really interesting edge cases that you get into when you start picking that apart about things like, well, what if you have an if-def around the definition? So then do you just replace those with const_exprs, or do you try to lift it out, or is there some other way to handle that? It's interesting.
So that feature works not just with regular old pound defines. I mean, it works with function style macros also. Is that correct?
I don't know what eventually got shipped in the product. I know that certainly we discussed the full gamut of all of the possibilities, and I'm sure that they shipped the part of it that they were confident they could do without kind of compromising your code in a certain sense, right?
Right.
Because in Visual Studio, we tend to be conservative on these. So you'll know if you've ever used the rename, right? If we have any doubts at all about what should or shouldn't be renamed, we ask you. We don't just aggressively go ahead and do it. And so I would assume that we did something similar.
Yeah, I could imagine there could be some really tricky cases where, say, you're intentionally duplicating the code that was part of the macro expansion. I mean, this is min and max and macros is notoriously difficult to actually get 100% correct, right? So all of the things that you have to do to guard your user from themselves, do you want that ending up in your const_expr function? Probably not.
Okay. And then the next one we have is call for a more diverse program at Meeting C++ 2018. Jens Veller obviously is hosting Meeting C++ again, and he decided to delay the call for speaker announcement or deadline another week, so that if you're currently at Rapperswil, which Robert, I believe you're there right now, and you want to go to Meeting C++ this year, you got an extra week, so you can finish out the ISO C++ meeting, and then you'll have a week before the speaker deadline.
That's great.
Yeah,
I think there's an interesting detail in here that was somehow completely lost on me last year. And Jens says, Meeting C++ will dedicate a track to... Oh, sorry, I'm just need to start backward. Last year's track for new speakers was a great success. I did not realize that one of the tracks was dedicated to first-time speakers.
Yeah, I thought that was a really good idea, too, and I'm glad he's going to continue with it again this year.
Yeah, it might be difficult for some of the really small conferences to do that kind of thing. I mean, we've talked about Pacific++, they're a relatively small conference, and CPP on C. Phil's conference is coming. They have their call for papers out right now. But, certainly I feel like any of the bigger ones could totally do something, at least dedicate a portion of the conference to new speakers.
Yeah, definitely seems like it would make sense for Meeting C++, and maybe CppCon could do something like that.
Yeah.
Yeah, I'd love to see that at CppCon.
That'd be really interesting. I mean, CppCon's huge, and it would I guess if John is listening, he can take that as a vote. Three of us think that would be interesting.
Of course, they already have had their call for submissions, and they're reviewing all of those submissions now. But I'm sure they get enough first-time speaker submissions to warrant, maybe kind of highlighting that content in some way.
Yeah, I know one of my previous students has submitted something, and it'll be his first submission to a conference.
Yeah,
I think he ended up calling for more reviewers, actually, because of the number of submissions he got. So there's probably enough in there.
Yeah.
Okay, and then the last thing we wanted to talk about was Conan 1.4 update. And it looks like the big announcement here is SCM integration, new CMake generators, and also better Visual Studio management.
Oh, I missed the better Visual Studio. Oh, look, it's right there. That's good. But yeah, it looks like it's going to definitely clean up their integration with CMake also. Yeah. And, we just keep talking about package managers, so I thought we may as well cover the announcement of a new release of Conan.
Yeah. And it looks... go ahead.
Oh, I was going to say this release came out like 2 weeks after I recorded my episode about Conan, and it might have affected my experience with how the CMake integration went.
Oh, okay. So you think you may have had a better experience with this new feature?
Well, the CMake part of it was pretty straightforward. It's just like 3 lines or something. But it might have been, it would have at least changed my sample code.
Gotcha. Okay. Okay, well, since we're talking about package managers anyway, Robert, do you want to start off by giving us an overview of Vcpkg?
Right. So Vcpkg is a library dependency manager. So what that means is that we're primarily focused on dealing with kind of the other people's code that goes into your code. So we're not a build system. We don't want to replace your build system. Build systems are thoroughly interesting, but everyone currently is undecided, I would say. There's not a general consensus about what actually the best one is, and I think there's some really interesting developments happening in that area. So to can that off, we're not that. We deal with bringing other people's code into your project. We primarily build from source, and then if you want to do binary caching, then we integrate with another system to do that binary caching. So you can use any binary caching mechanism that you want. You can use NuGet, you can use zip files, you can just throw the binaries out on a network share, whatever you want to do with that. We have specific integration mechanisms for MS-Build, which is Visual Studio's build system, and CMake, but we explicitly lay out the files in such a simple way that for any other build system that wants to use them, it is trivial. It's just a very small set of command line flags, and you're ready to go. So, I think that's pretty much the short summary. And yeah, Jason, you took a look at it as well, I understand.
Yeah, I just played with Vcpkg a little bit in one of my most recent episodes of C++ Weekly, but I kind of wanted to unpack what you were talking about with binary caching. So when you go to install a package with Vcpkg, it's going to build it from source. What happens to the built thing?
Right, so it gets built on your machine with your tools, so your particular tool chain, and then those binaries are made available for your build system, and this can come in any of the ways that I described before. And let's see, if you are using MS-Build or CMake, you can, or any other build system, if you add the right flags, you can pull binaries directly from our system. However, there are a lot of cases where you don't necessarily want to build these binaries on every machine. So, if you're at a company, you very often will have a small set of people dedicated to dealing with the outside world who need to bring in the tested, understood, particular versions of things that you want to use that are built with the tools that you want them to be built against and in the ways you want them to be built. And then you want to package them up for consumption by everyone else in the company in kind of like a shrink-wrapped form. And that is how Vcpkg approaches the problem, is a particular Vcpkg instance can be used to build the machine. And if you're just an enthusiast at home, this is what you do on your home machine, is you would build those libraries using your tools. But in a larger organization, you would build those tools once, or you would build the binaries once, and then you would package them up in something like NuGet or something like zip. And we do this automatically for you. All you have to do is say, hey, I want a NuGet, and we'll give you NuGet. Okay. But then you can consume that one on your CI machines, or you can deploy it to all of your developers, or you could upload that zip of all of your dependency binaries to GitHub, and then anyone online who wants to replicate exactly how you build your thing, those are the exact binaries that you used to build it. So that's how we layer the problems so that, as part of any good engineering strategy, right, you want to try to break the problem into as small of pieces as possible so that you can do a really good job at solving that piece. And so that's how we layer the problem.
So if I install the package, it's available to all of the build systems and tools and whatever that I'm building on my system. It's just always going to be available there.
It depends on the particular strategy. So the way that you probably used it in your episode, and I believe I recall that you did so, is we do have a user-wide integration mode. And this user-wide integration mode is the way that Visual Studio will work by default. So if you use our user-wide integration, then you just write, vcpkg install, say, SDL2. And then you'll go to Visual Studio, you'll do File, New Project, you'll grab some sample code online, you'll paste it into Visual Studio, and it'll build and it'll run.
Okay.
That's it.
Just automatically knows that there's this cache of things that have been done.
Right. And that linkage happened because of that user-wide integration command. However, that's not the only way to use it, because that by itself isn't sufficient, especially when you start getting into more complex scenarios. I've got multiple projects. They have different requirements on exactly what binaries they want to use. Maybe I have one set of dependencies that I want to use for my company projects, one set of dependencies that I want to use for my private projects. And in this way, you can link the individual vcpkg instances. So another way that I would say it is that a particular vcpkg instance, so that's a git clone, and then with all the binaries inside of there, a particular instance looks like a system-wide manager to your project, but it can act on any scope that you need. So it can be on a per project basis if you want. You can just make a new one for every project, or it can be on a user-wide basis, or it could even be on a system-wide basis if you want.
Okay.
And that choice is made by how you particularly integrate. So in CMake, we ask you to supply a toolchain file from us. So we provide a toolchain file that you specify when you do your CMake configure, and that toolchain file lives inside the instance. So it's very clear when you use a toolchain file, that's the instance that you're getting binaries from.
Okay.
And so the way you can use multiple instances is trivial. You just use the toolchain file from the instance you want to get the binaries from.
All right, interesting.
If that makes some amount of conceptual sense.
I think it does, yeah.
To back up a little bit, so Jason has gone through this process for his C++ weekly video, but
just for the record, I did not realize we were having you on when I recorded all those episodes.
No, you did a great job.
Well, if you're just getting started, though, how easy is it to get started with using vcpkg as a package manager?
So on GitHub, we've got a quick start instructions. It's all on one page. You don't even have to click any links. You just git clone, run a bats file, run one command to do the user-wide integration because that's the easiest way to do things, and then install whatever libraries you want, and you're done. That's it. You can now, if you're in Windows, you can open up Visual Studio, and you can just immediately start pound including and using the code, and it just works out of the box. You don't need to worry about the link line. We deal with that. So it is pretty magic. I'm always pleased to introduce vcpkg to users who haven't used it before, because they go through this experience and they're just like, oh my god, this can't be C++. This is way too easy. And it's a wonderful It's a wonderful thing. Now, if you're using CMake, we took a slightly different approach to CMake because CMake has a well-defined mechanism that you should use to find your dependencies, and that's the find package mechanism. And that's an official CMake thing, like this is the blessed way of dealing with packages. You should not be using any package manager specific thing. So we integrate directly into that, and that's via the toolchain file. So the toolchain file makes sure that the binaries from Vcpkg can be found from the find package commands that you execute in your CMake. And this means that your CMake file is 100% Vcpkg agnostic. The same build system that you will use to build against apt, the same build system you use against homebrew, the same build system you would use against any other system, that's the one that you use for Vcpkg. You don't have to have, like, if this, then that. And we think that this is really important in a world where there are multiple package managers, because that's not going to go away anytime soon. If you want to be in homebrew, if you want to be in apt, if you want to write software for these wonderful ecosystems, you have to be able to accept dependencies from them. This is like a core requirement of the Debian packaging guidelines. You cannot vendor your own dependencies. You need to use ours for security, for stability, for maintainability. So you must use a system that will be agnostic, and that's why we've designed our integration in this way, is it is agnostic with the way you write your CMake file.
So,
and
yeah. Oh, go ahead.
No, that's all I had.
You said you just say that you vcpkg install whatever package name, and then it's basically magically there for you. But is it the release build, debug build, 32-bit, 64-bit, and on Windows, like if I want a Clang build, a CL build, and a MinGW build, like what was just built for me? And what happens in Visual Studio if I go and change my target to debug or to 32-bit or whatever?
Right. So we currently always build release and debug because we don't view debugability as optional.
Okay.
So we always build release and debug, and those are chosen for you based on your release and debug setting. Now, for architectures and for CRT settings, things are slightly more interesting. We, in a particular Vcpkg instance, the binary graph is split for every target, and we call targets triplets after the well-known concept, if you're familiar with it, the concept of a target triplet. So when you install a library with Vcpkg, and you write Vcpkg install zlib, for example, you'll notice that it immediately comes up and says zlib : x86-Windows. So x86-Windows is the target triplet.
Okay.
So that's the graph, the universe that it's installing into, and it's building this package in a way that will be compatible with that universe, which in the case of x86 Windows is MSVC V140 or V141 with a dynamically linked CRT, where most of your dependencies are expected to be DLLs, and that's that. All of that information is specified underneath the name x86-Windows. And specifically, it is encoded in a file called x86-windows.cmake in the triplets folder. And you can create new ones of those that have whatever settings you want. You can change any of these settings. You can say, I want to use a static CRT. I want to static link the libraries. I want to use a different version of the compiler. I want to use a completely different compiler. All of those things can be specified inside that triplet file. So the triplet file is meant to denote kind of a completely independent graph of packages, because if you write a piece of software, you're going to target maybe Linux and x86 Windows and x64 Windows and some other system. And each one of these universes, each one of these kind of imaginary future processes, right? Because eventually you're going to run this program and it's going to live in a process somewhere. The idea is that each one of these processes is kind of its own universe, and so you're targeting a particular universe with a given triplet, and so that's the way we conceptualize it. So to answer your concrete questions, when you wrote Vcpkg install zlib, you got the MSVC dynamic CRT x86. But if you wanted a different one, you just write : the other triplet that you want, so x64 Windows or x86 Windows static, or maybe ARM UWP, or whatever it is that you want to build.
So I hypothetically just built and installed the default thing, and then I go into my project and I choose, assuming this is even still an option, it's been a while since I've even looked, I choose that I don't want Unicode CRT, I want the ANSI CRT or whatever, right, which is going to change which CRT I link to. Is that still an option? Okay.
That is not. I do not believe we have a non-Unicode CRT, but I could be mistaken.
I know it used to be a thing.
Yes, it used to be a thing, but I don't think that's a thing.
So in my hypothetical universe, I've done this, and then I go to build my project. I'll just get like a package not found kind of error, or is that what would happen?
In an ideal world, that is what would happen. Now, in the particular case of Visual Studio, in the particular case of MS Build, in the particular case of the CRT, we unfortunately found that we couldn't automatically switch based on the CRT, which is an enormous shame. So
there are still multiple CRTs available then, right?
Yes. Yeah, static and dynamic, and release and debug.
Okay.
So we deal with release debug, but we don't deal with static dynamic, and that does matter. So if you link against the static CRT/MT or the dynamic CRT/MD, those two are link incompatible. Your entire process really needs to be using the same one. And if you're using the static CRT, you better be static linking the world, because you're going to have problems otherwise.
Right.
So we unfortunately were unable to automatically switch based on that setting. And in that setting, you'll get a linker error saying, hey, you're trying to link a library that uses the dynamic CRT and you're using the static CRT, and those aren't okay. So you will get an error in that case for the linker. And the way that you resolve that is you just have to manually override which VC package triplet that you're using. Now, in the case of targeting x86 or x64, though, we will automatically choose the right triplet. So when you do the platform dropdown and you say x64, we will automatically switch over and start using x64-Windows to get packages from, in which case you get a package not found error like you expected.
Okay. Now, I guess this might be a good moment to for our listeners who don't know, what is the CRT?
Right. The CRT is... I loved a quote based off of the movie, I believe, The Usual Suspects, which is, the greatest trick that C ever pulled was convincing the world it didn't have a runtime.
Okay.
So the CRT is the C runtime, the library that implements all of the C functions that you're familiar with, malloc and memset, memcopy, and all of these wonderful functions. And so it becomes very important that you and any libraries that you use agree on what malloc means, because if you don't agree, and they malloc something and you try to free it, and, well, their malloc allocated things over here and your free expects them to be over here, bad things happen. Very bad things happen very quickly. So, fortunately, I can't claim credit for this, but I'll claim credit on behalf of my team. We do have some mechanisms in place to detect this at link time, so you don't have to wait until runtime to figure out that your program has a problem. So it will, it's called pragma mismatch, so that's named off of the mechanism you use to inject one of these detection things. But basically, the point is that when the linker tries to slam some objects from over here into your objects from over here, it'll say, these have a little tag in them that says they were using the debug CRT, or the dynamic CRT, and these say that they're using the static CRT, and those are not okay to put together in the same program. And so,
that's cool.
Yeah.
Yeah, I've had some direct experience, and this used to be the case, I don't know if it still is, that the libruby, the official binary for Windows, exports its own versions of things like free and malloc and printf, and it can really screw with the runtime behavior of your program. It is literally the worst thing I've ever had to deal with as a programmer. But anyhow.
Better stick with C++, I guess.
I wanted to interrupt this discussion for just a moment to bring you a word from our sponsors. Backtrace is a debugging platform that improves software quality, reliability, and support by bringing deep introspection and automation throughout the software error lifecycle. Spend less time debugging and reduce your mean time to resolution by using the first and only platform to combine symbolic debugging, error aggregation, and state analysis. At the time of error, Backtrace jumps into action, capturing detailed dumps of application and environmental state. Backtrace then performs automated analysis on process memory and executable code to classify errors and highlight important signals such as heap corruption, malware, and much more. This data is aggregated and archived in a centralized object store, providing your team a single system to investigate errors across your environments. Join industry leaders like Fastly, Message Systems, and AppNexus that use Backtrace to modernize their debugging infrastructure. It's free to try, minutes to set up, fully featured with no commitment necessary. Check them out at backtrace.io/CppCast. So you mentioned Debian and a couple other Linux platforms a moment ago. When Vcpkg first started, it was Windows only, but you did recently expand. What are the total platforms you support now?
So we build the entire package graph daily for Windows and Ubuntu and OS X. However, we know that people have been successful internally and externally using us for, Arch Linux, for Debian, for FreeBSD, and also for cross-targeting for things like Android or iOS and Emscripten. So all of these things are possible. We just don't currently build them on a regular basis to the point where we would want to say, yeah, these are, officially supported. That's not to say that if you file a bug, we won't fix it. We would love to hear about any issues, but it's just those aren't in our CI system yet. Someday, maybe, and I would love to get there, but they aren't in there yet, so that's why they're not on the official list.
When I played with it, I was using a derivative of Arch and didn't notice any distribution-specific issues. Nothing that I saw.
Just out of curiosity, when you first started working on Vcpkg, did you plan that you would eventually support, Linux and OS X, or did you think it would just remain Windows only?
I would say that as a C++ developer, not necessarily as a Microsoft employee, but as a C++ developer, one of the great things about C++ is that it is cross-platform. You can write code, and it can compile natively to dozens, if not hundreds, of different platforms just out of the box. And so any sort of package manager for C++ really does need to keep that in mind. It really does need to be able to, at least in principle, handle that. So certainly from day one, we already kind of had the ability to have cross-targeting. So not necessarily being hosted on a different platform, though in principle there's no real difference, but certainly cross-targeting was in there from day one because of UWP. So for those who are unaware, UWP, this is the Universal Windows Platform. It's basically the Windows Store model. It's the next generation of Windows APIs compared to, say, Win32. So these are the new APIs, and it's a new protocol that lets you do a bunch of fun things about language interop. And if you want to, have live tiles or interact with the notification system, these APIs are being added in UWP and WinRT, which is the next generation of the operating system APIs. So from day one, though, a lot of programs can be compiled either for UWP or for Win32, the legacy desktop system. So we, from day one, had that cross-compilation idea baked in.
Right.
Okay.
And so, from there, it's a natural extension that, well, of course we can target Linux. Of course we can target Emscripten. Of course we can target phones. I mean, they're just different. You just have to be able to change the switches out from underneath and then change the compiler out from underneath. But that's totally a normal thing to do. So I would say that from the beginning, the architecture was there, even if the code wasn't. But we're engineers, we can fix code. So it's not a problem.
So would you say that the support for Windows Linux and Mac OS is fully stable, mature at this point?
There are some, I don't want to say that we don't want to improve it, right? So we definitely want to continue improving it. So a notable, I don't want to say gap, but a notable thing that we've chosen to do for now is that we are focusing on static linking only on Mac and Linux. And this is due to some of the troubles about deploying dynamic libraries. So if you're consuming from a system package manager, then the story about dynamic libraries and shared objects is pretty simple. They're going to be in user lib, and that is where you get them. And if you want to move your application to another system, it either needs to be exactly the same, or you need to rebuild it for that new system. And that's pretty much the story. However, for something that's more project local, something that intends to more support kind of a cross-platform compilation framework, it's not clear what we would do if we built shared objects for you. We would have to say, well, we built these shared objects for you, but now you need to either embed our path, in which case moving it around becomes difficult, or you have to use the LD library path, like shell environment variable with a shell script that jumps into the actual program. So these were some challenges that we don't know how to solve yet, and I would love if anyone in the audience has some ideas and they'd love to chat with us about that. I would be more than happy to chat with you about it. But it's a problem that we didn't feel we could solve really well, and so we haven't focused on shared objects yet. And so we're pretty much focused on static libraries.
Well, then on the Windows, how do you solve that problem? Like, do you provide like packaging support in CMake or something, so it knows where to get the DLLs to shove them into the installer or something like that?
Something like that, yeah. So we add a post-build step, which does analysis of your binary and figures out the transitive closure of all your dependencies, and then what we call app locals all of the DLLs. So right. App local is a term for putting a dependency DLL in the same folder as the executable, which causes the loader to be able to find it. And so right. you take all the dependencies and you put them in the folder, and now they're all available, and you can just zip up the whole thing and put it on any machine anywhere, and it works. So that's a pretty straightforward story.
Okay.
Another question is the GitHub page for Vcpkg still says that the tools and ecosystem are currently in preview state, and obviously you just mentioned you're soliciting open source contributions. How long do you think it's going to remain a preview state tool?
So obviously I can't
Sure.
guarantee anything because things change, right? I'd like to look at moving out of preview nearer rather than farther. One of the big things that we want to do.
That's very specific. One of the things that we want to do.
Yeah. One of the things we want to do as part of moving out of preview, though, is drastically improving our enterprise support. So we know a lot of businesses are successful in using Vcpkg already, but there are some things that we really want to improve upon before we say, we're out of preview. Some of these things are we want to improve the ability to shrink wrap your dependencies ahead of time. So, and I don't mean the binaries, I mean the sources. So being able to, say, redirect all of the source fetches to a private server that you control, so you have complete guarantees that, a GitHub repo isn't going to just disappear out from under you tomorrow. Right. Or the public version of something is not going to disappear out from underneath you tomorrow. Now, because Vcpkg is based on Git, and you just do a Git clone, we, in that repo, deliver the entire history of all of the recipes and the entire tool source, because that's part of the batch file that you run, is it actually builds the tool on your machine. So you have everything from us that you need. Even if our GitHub repo disappeared, everything would continue to work. But the problem is that the library that you're building itself, we fetch the sources from their upstream currently. So, we fetch Boost sources from the Boost org repository on GitHub. So they have subrepos for all of the individual Boost libraries. We fetch those repos, and that means that if those repos were deleted, then that could cause problems. And so one of the things that we want to address for companies is the ability to say, look, these are the recipes that I want to use. Can you pre-download everything? Can you pre-download everything, put them all on a private HTTP server, for example, and then redirect all future requests to that server? And if you ask for anything that isn't on that server, fail so that we know that we are missing a dependency. Something like this. So that's a place where we really want to improve our support. And we also think that enterprises will probably want to go further than we currently have with the idea of binary caching. So our current mechanisms, where we can dump the binaries into a raw folder, or we can dump them into a zip file, or a 7-zip file, or a NuGet package, or a Qt-IFW-based installer. That was an export mechanism that was contributed by another user. So I'm not fully versed in how it works, but it appears to be like an SDK style installer. If you remember, downloading an MSI for some precompiled library and installing it on your machine and having it available, it looks like it's a mechanism for doing something like that. But we know that enterprises are going to have very particular concerns about how, well, we don't really want it all to go into one NuGet package. We want it to be split up across different NuGet packages in this particular way, and we want to do more in that direction. So these are the two areas. These are two of the areas that we would like to improve enterprise support before calling it, stable version 1. But I don't think that will change our approach to development. We believe that package management it's an ongoing process. It's not something like a box that you just ship and it's done. It's an ongoing, continual, incremental improvement process that really stops being useful if it stops changing.
Okay. I was wondering if we could ask you any questions about how the Rapperswil committee meeting is going, since you're over there right now.
Yeah, so this is my first committee meeting, so it's an interesting experience. Well, first committee meeting and second time out of North America, so doubly interesting experience.
Oh, wow.
I love the trains; they're fantastic. I highly recommend riding on them if you ever get a chance. But the committee meeting is really interesting. I have generally been sitting in EWG, not LEWG, as you might imagine, being a package manager author. But I've been working with modules and coroutines. Right. And so those two were two of the big areas that were on the docket for EWG. And sorry, I should step back a second. The EWG is the Evolution Working Group, and so this is the group that discusses and tries to hammer out the directions for the future of the core language. So that's not the standard library. These are things like lambdas or auto or type aliases, so template type aliases. These are all things that come from EWG. Then there's a CWG, which is the core working group, and they're the ones who make sure that EWG didn't make too many mistakes. So they hammer out all of the little details in the wording of exactly how this should be specified, because obviously C++ is backed by a standard, and so what that standard says is really important because the compiler writers are expected to implement that, not what they just felt like implementing. So I've been attending EWG, and some of the big things that have been discussed were modules, and coroutines was today. And then on Monday, they discussed modifying the constructor for string view, which is interesting.
In what way?
So string view, as it's currently spec'd out, will take a pointer and a size, or maybe two pointers, I forget. But the idea is that string view in its current specification is intended to model a string. This begs the question, well, a string, and not just a string. It's intended to kind of model const char star from C, except it's length counted. But this begs the question: const char star can be set to null pointer. Is null pointer a string, or is it not a string? Is it an empty string? If you dereference it, it's not a null byte, which is really kind of what we expect from an empty string. So what is it? And the discussion about string view primarily revolved around what is string view really intended to model, and is this or is this not a string, and how should we treat it? So there was a proposal to make it so that string view would accept null pointer as a constructor argument, and it would initialize the string view like it was an empty string. That was the proposal. The status quo was that it would be UB, because you gave us not a string, and string view views strings. You gave us not a string, so you gave us garbage, so UB. The standard C++ answer to these things. And in the end, there was not consensus to modify the constructor.
So as is, we'll stay with current behavior, which is UB?
At this point. I mean, obviously, things can change, and I wouldn't be surprised if it comes up again in, I believe the next meeting will be San Diego, but on Monday there was not consensus.
That's pretty interesting.
Yeah, it's an interesting thing. Now, the funny part is that you can still get a null pointer 0 string by default constructing it. Yeah,
default construction. I was just playing with that yesterday myself, and I was somewhat surprised, but at the same time glad that it existed, because I kind of needed it.
Yep. Well, and that was an argument brought up from one side of the table. So it's it's an interesting thing. But yeah, modules and coroutines, pretty much all day affairs, a big slog. But progress was made in both counts. I think some interesting points were raised, and we dug through a bunch of proposals. So.
But no specific news, of course, yet.
Yeah. I don't want to affect the proceedings that still remain to occur, like things. So there's a section of the meeting called plenary, which is kind of like people break up into these individual sub-working groups, but then everyone comes back together for plenary, where everyone gets to come together and decide that, yes, this is truly the great future that C++ will be, or no, you guys really didn't think about this enough and you need to go back and keep hammering on it. And so plenary is still to come for a lot of these things, and so I don't want to say one way or another about how that'll go.
Okay.
Well, we'll have some exciting news to talk about in a week or so after everything's done.
Yeah, yeah, definitely look forward to the trip reports.
Yeah. Sorry, go ahead, Jason.
No, that's all right. There's also supposed to be like tools working group or whatever kind of discussions, right? Have you been involved in that at all this week?
That's right. That's primarily why I'm here, is for the tooling working group, SG15, which will be meeting on Friday evening. So
on Friday evening? That's like the final hour, right?
There's a Saturday. There's some stuff on Saturday. So
okay.
Yeah, it's a long haul. It's a long haul. But no, I'm really looking forward to that. That's headed by Titus Winters of Google fame, and so it's going to be good. It's going to be good.
Awesome. Well, I'm glad you'll be able to go there with your background with Vcpkg and everything. I'm sure you should have some interesting contributions for it.
I hope to. Yeah.
Okay. Well, is there anything else you want to talk about today before we let you go?
Let's see. No, I think that's awesome. I think we dug through Vcpkg a bit, and I'd like to let the audience know that we're an open source project. We're on GitHub, github.com/Microsoft/VCPackage. We completely 100% accept contribution. Well, sorry, I don't mean to say we accept 100% of contributions, but we are very much open to contributions. Of the 700 plus libraries that we have, all but 30 of them were externally contributed. So yeah, we accept contributions quite a bit. It's really about a community of maintainers more than it is about just a single tool. It's really about the ecosystem. That's what it's about. So I wouldn't. Okay. Please don't hesitate to come by and let us know.
All right.
Okay. Thanks so much for your time today, Robert.
Yeah, it's great being.
Thanks for joining us.
Thanks so much for listening in as we chat about C++. I'd love to hear what you think of the podcast. Please let me know if we're discussing the stuff you're interested in. Or if you have a suggestion for a topic, I'd love to hear about that too. You can email all your thoughts to feedback@cppcast.com. I'd also appreciate if you like CppCast on Facebook and follow CppCast on Twitter. You can also follow me at Rob W. Irving and Jason at LeftKiss on Twitter. And of course, you can find all that info and the show notes on the podcast website at CppCast.com. Theme music for this episode is provided by podcastthemes.com. Website at CppCast.com. Theme music for this episode is provided by podcastthemes.com.